Hello students, in the last episode we learned about printing of fabrics using hand methods, but today we will learn about the printing of fabrics using the machinery. These machinery printing methods, they employ specific machines for production of the prints on the fabrics in large quantities at a very faster rate, but it may require some more investment when compared to the hand methods, but as the fabrics are being printed at a very faster rate, the expenditure on the each meter of the fabric comes down, and so some of these are being employed by many companies, and roller printing may be one of the oldest methods of mechanical printing that is being in practice since 1783. A roller printing machine consists of a big cylinder which acts as a backing for printing along with a blanket, engraved printing rolls, color boxes, furnished rolls, doctor blades, etc. will form all the roller printing assembly. For each color to be applied, there is one print roll, one furnished roll, one color box and one doctor blade. Roller printing machines generally have 8 print rolls. Some are also equipped today with 18 rolls. It depends upon the colors that are being used in the design. For preparation of the print rolls, depending upon the number of colors assigned for each part of the design, those many print rolls have to be made ready for printing. The areas of the design that require a certain color are etched or carved on a copper roll with one roll for each color. Different methods of etching of the roll are in vogue. Coming to the method of printing, the blanket and the backing material, generally a grey material, is made to pass along with the fabric to be printed between the big cylinder and the print rolls, which are placed over a color box. Each color box is equipped with a furnished roll which picks up the color paste from the color box and continuously fill the etched areas of the print rolls. A doctor blade scrapes off any print paste coming on the raised areas other than the design areas. Thus, the print paste will be present only on the print design area. This print paste is transferred onto the fabric surface through the pressing of the print roll as the fabric moves continuously between the print roll and the central cylinder backed by a blanket and a grey fabric. The grey fabric and the blanket absorbs the excess print paste so that it does not become deposited on the drum. Printing is carried out at a rate of 6,000 yards per hour or over 100 to 150 meters per minute. The fabrics are further processed depending upon the colorant used. It will be subjected to dry heat up to 240 degrees Fahrenheit to fix the pigments used for printing. If dyes are used, it may be steamed or autoclaved to fix the dye. Then coming to the next type of printing, that is flatbed screen printing. Screen printing done manually is the forerunner of flatbed screen printing, which was started in 1940s by mechanizing the screen printing process. The equipment consists of a long table over which a continuous rubber belt moves, fabric guiding rolls, flat screens that are mounted above the table and a squeegee in each screen. And for preparing the screens are originally prepared with silk cloth and used to be called as silk screen printing. At present, screens are made with nylon, polyester or metal. The material is referred to as bolting cloth. Nylon bolting cloth is popular among other fabrics. The fabric has twisted filament ions made in plain weave with well defined interstices to allow printing paste to pass through. The screens are prepared using a photochemical process. The basic screen is prepared by fixing the bolting cloth in the rectangular frame which represents the dimensions of the fabrics on which it is going to be printed. To prepare the screen, it is coated with a light sensitive lacquer covered with a negative of the design and expose it to light. The light exposed areas harden, leaving the design areas to become water soluble. The screens are washed to remove the loose lacquer so that the design areas are well opened. The hardened areas are again coated with a suitable non-reactive paint. When the paint is put up on the screen, it passes only in the design area. The number of screens required for printing depends upon the number of colors present in the design. For printing, the fabric to be printed enters the printing area at one end of the table, where it is positioned to align with the screens and emerges at the other end. During printing, a wide rubber belt moves the fabric an established distance. The fabric and the belt stop moving. The prepared print screens are lowered onto the fabric and the printing paste is forced automatically through the open design areas of the screen by the squeegee. Then the screen is raised and the fabric is moved, exposing the unprinted area. The movement is synonymous with the width of the screen, which is done automatically. Depending upon the number of colors in the design, that many number of screens are lowered and pass the colors in the form of a stipulated design. The modern flatbed screen printing may be expensive as compared to the hand screen printing, but it will print up to 20 colors in one run. The versatility and the production speeds compensate the higher initial investment in this. The speed of the machine is around 450 to 500 yards per hour. The advantages of the printing process are: the investment is less when compared to the roller printing, where the rollers are more expensive than the screens. Changing the designs is easier and economical, as the screen making is not expensive as in case of roller printing. The colors can be produced in brighter, cleaner shades than are possible with roller printing. The designs to be repeated can be much larger. The technique lends itself to experimental and creative designs. Short runs of unique designs are being sought by couturiers and interior decorators. Geometrical designs are easily be replicated on screens, unlike cardboard and metal stencils, where the cut area in case of circles, squares, ovals, etc. will fall away. Knitted fabrics are safely be printed with screen printing. The other roller printing methods smudge the printing paste as the fabric stretches while passing through the rollers, and so this will be the best method of printing the knitted fabrics. Then let us see rotary screen printing. The process of printing using seamless cylindrical screens made out of metal foil is called as rotary screen printing. This process is originally developed in Holland in 1963. The printing assembly consists of a table, a wide rubber belt to move the fabric and provide backing to printing, rotary screens with a squeegee, each for pushing the printing paste through the screens inside the cylinder. Coming to the method of printing, the fabric to be printed is moved on a belt with uniform tension. Sometimes the back of the fabric is coated with an adhesive so that it adheres to the belt and does not slip from the path. The belt along with the fabric is moved under the rotating screen, which print the fabric each in one color, being supplied from the pressure tanks automatically. The number of rotary screens depends on the color scheme of the design. It has several production advantages as compared to roller printing. Production rates of 2500 to 3500 yards of fabric for 1 hour are possible. Fewer out of register patterns are produced. Changeover times are faster. Pattern changeovers are easier because the screens weigh about 4.5 kg each compared to 91 kg of copper rolls. The cost of rotary screen is less, and there is a shorter apprentice time for printers and less chance for human errors in this kind of printing methods. Rotary screen printing is efficient for long as well as moderately small production runs. The screens do not last long as copper print rolls. The print color depth is similar to or as good as that of flat screens. It is possible to print various types of intricate designs with shades of up to 20 colors with a high degree of accuracy and sharpness. Then let us see another very inexpensive method called spray printing. Spray printing is a method of printing that utilizes airbrushes for spraying the color on fabric. This is the most inexpensive method of printing a large area of fabric very quickly. The dye may be blowed or sprayed on fabric using a mechanical airbrushes. It is possible to use number of colors for spraying on fabric. Sometimes stencils are used if spray effect in a design form are required. Direct, acid, vat or pigment dyes may be used for this type of printing. Then coming to another novel method of printing, that is transfer printing. It is done on fabrics, especially knits, and it was developed during 1960s in France. By simple heat process, a design printed on a piece of paper is transferred to the fabric using modified garment presses. The dyes used are capable of vaporizing under the heat conditions of the presses and had a high affinity for the fabrics. In this method, the dyes should be of sublimating type and hence the process is often called sublimation printing. Dispersed dyes are capable of sublimating, that is, they form a gas directly from the solid state at a high temperature. It has provided good solution for printing difficulties for fabrics such as polyester and which posed problems in dyeing and printing earlier. Coming to the method of printing, modified calendaring machines running at elevated temperatures have been adopted for this printing. Continuous rolls of paper printed with the design form an essential element in this printing. The roll of pre-printed paper and that of the fabric are held together so that the print faces the fabric and are made to pass between a central heated cylinder and a continuous process blanket. Only light pressure is required for the transferring of the print at a temperature in the range of around 200 degrees Celsius for 15 to 20 seconds. The dispersed dyes on the paper sublime at this high temperature and are absorbed into the fabric and which is in contact. Fabrics such as polyester, acrylic, nylon or acetate are printed in this manner. The advantages of this process are no further processing is required here once the dye is transferred, and there are no pollution hazards associated with printing, and heat transfer printed fabrics have an unmatchable sharpness and clarity of design and shading. Fabric print defects of 5 to 10% in case of screen and roller printed equipment are avoided in transfer printing, as prior inspection of the print paper avoids any kind of defects. The used paper retains the original design in muted colors and are sometimes sold as wrapping paper to consumers, or sometimes they are made into bags and sold to specialty stores. The production costs are reduced as after treatments such as steaming, curing are eliminated. Generally, no seconds are produced with this type of printing. Fabrics generally have a better hand because the dyes are applied in a very thin form, and so it does not alter the fabric handle, and a wide range of patterns in great many colors including rich and deep shades may be produced in this type of printing. Another method of printing where the dies are not used is called as flock printing. It is a unique printing technique in which minute pieces of fiber is made to adhere in a standing position to form a velvet-like design on the fabric. The technique has been used over 600 years to a limited extent. It is used widely at present in the context of non-pollution, as the dyes and chemicals are not used in this method. However, dyed fiber pieces are being used. Coming to the method of printing, a suitable adhesive is roller printed on the fabric in the form of a design. Then flock is applied on the fabric in a manner that causes it to adhere in an upright position and produce a pile-like velvet textured design. Practically, all manufactured fibers can be used for the flock. However, precision cut rayon and nylon, that means with a square bottom, are more popular for making the flock, the length of which may range from 2/25 to 1/4 inch. The mechanical method of flocking involves beating the underside of the adhesive coated fabric with rotating multi-shed beater bars as the flock is sifted onto the surface of the fabric. The fabric's vibrations produced by the beater bars cause the flock to flow over the surface of the fabric and stand erect those fibers that do not land flat on the adhesive. Continued vibration causes the erect fibers to penetrate deeper into the adhesive, and as more fibers fall on the already erect fibers, they become similarly oriented and build up a pile-like effect. With this method, the fibers become more deeply embedded and therefore more permanently attached. And another technique that utilizes electrostatic field for making the flock to stand erect. As the flock is sifted onto the fabric, it passes through an electrostatic field. This directs and propels the fibers in the longitudinal direction of the current towards the fabric, which causes them to stick to the adhesive in the upright position. This method can produce denser flocking as the fibers uniformly adhere upright to the fabric. This method of flocking may be expensive than the mechanical method of production of flock. Depending upon the background fabric or substrate, the depth of the pile, the flock used and the pattern, flocked fabrics may be created for various purposes. Flocking is used for household goods such as curtains, draperies, carpet and wearing apparel. Coming to another method of printing, that is called photo printing. As the name indicates, it resembles printing of photos on a fabric. The fabric is coated with a photosensitive chemical. Any photograph may be printed on the fabric with much clarity and shading effects seen in photographs on paper. A sophisticated form of photo printing is a cymatic process developed using oscillations of musical chords which are caught on a quartz plate. The patterns that are formed on the plate are photographed and the colored pictures are reproduced on fabric. A novel type of printing that is coming today in the market or the fabric digital printing. So, with the advent of the technology in fabric printing, innovations are always in the forefront. One such technology which became popular in the recent years is digital fabric printing. In the 1990s, inkjet printers became widely available for paper printing applications. Further research in this field brought in printers which can handle a variety of substrates, everything from paper to canvas to vinyl and of course fabric. The inks used in digital printing are formulated specifically for each type of fiber, that means for cotton, silk, polyester, nylon, etc. And designs can be created digitally with almost any graphic design software, that is maybe a Photoshop and Illustrator, and these are the most popular ones. Alternatively, existing artwork or photographs can be scanned and then digitally manipulated to make them into a pattern. Usually, designs are created as a seamless pattern that is repeated across the fabric. Coming to the method of printing, during the printing process, the fabric is fed through the printer using rollers and ink is applied to the surface in the form of thousands of tiny droplets. The fabric is then finished using heat and or steam to cure the ink. So, some inks also require washing and drying. Digitally printed fabric will wash and wear the same way as the other fabrics, although with some types of ink, some initial fading may be found in the first wash. Thus, today we have seen many machine printed methods and we have seen that the methods have produced the fabrics at a very faster rate. Today, the industries are equipped with sophisticated equipment in order to satisfy the customer, because there is a quick response that is required in the industries to satisfy the customers. A customer comes with a swatch of material and that is easily reproduced by the mills at a very faster rate, and thus there is lot of scope for machine printing methods when compared to the hand printing methods. Because the investment is higher in these machine printing methods, maybe the price of the per meter may be little higher when compared to the hand printing methods, but since the prints are made at a higher or a faster rate, the price of the per meter it comes down, and thus these are more economical when compared to the hand methods of printing.